question 9. No, it's right down there. There we go. Mr. Quintana surveyed students about whether they agreed or disagreed with the statement, "I like school lunch." He recorded the income level of the student's family and the response for a random sample of 330 students. Statement: the distribution of liking school lunch and income level shows that middle income disagreed more with liking school lunch than low or high income, and low and high income both had about the same feelings about liking the school lunch or not. Which mosaic plot correctly displays these results? Come on, get out of the way. All right. So, now it's back in the middle again. This thing's going to drive me insane. All right. So the dark teal is disagreeing with liking school lunch. The lighter teal is agreeing with liking school lunch. And we know that middle income disagreed more. So the disagree bar for middle income should be higher than the agree bar. Disagreed more with liking school lunch than low or high income. So when I look at that, just the first part of this sentence, I can kind of narrow it down from there. Disagree should be higher on the middle than either the low or the high. Well, this one has low disagreeing the most, middle disagreeing in the middle, and high disagreeing the least. That's not what that statement is telling me. It's plot B right here. This one is higher for the disagree part, and the low and high are about the same feelings. So it would be this one right here, plot B. What else would you guys like to see? Which one? I'm sorry. 13 and Akeem?
I was going to do 12B.
12B and 13, sure. Let's do that.
Wait, not 12B.
Not 12B?
12C.
12C, okay. Write a few sentences comparing the nitrate concentrations in Stony Brook and Millbrook. I'm going to do 12C first, and then we'll go do 13, since that's, as I move through this, I run into that one first. All right, so describing these distributions. Oh my goodness. Hands are sticking together here. We have this data output right here. This is called Minitab data. Minitab is statistical software that is commonly used for statisticians. They feed a bunch of raw data into it, and then it spits out the total count, the mean. We'll talk about what SE mean is. That'll be a second semester thing. For now, you guys can just ignore it. This is just what those printouts look like. Standard deviation, and then our 5-number summary. Minimum, Q1, median, Q3, maximum. We want to write a few sentences that is comparing those. Thank you. There you are. So if I'm comparing these things, what's my acronym to help me remember? SOX. What does the first S stand for? Shape, O. Outliers, C. Center, the last S. Spread, or variability. And then things I have to remember. Context. And comparative language, because we're comparing here. So in that first sentence, I'm usually going to be getting some of that context in there as I talk about shape and outliers. I usually like to put that all into one sentence together. So what are these graphs of? Like, what did they tell you up in the stem of the problem or anywhere on the graph? What are we actually looking at here? Nitrate concentrations. So I would start with the distribution. of nitrate concentrations. Oops. For, and now I have to pick one of them to talk about first. Sorry, my handwriting is so poor. It's, if I write really neat, it's going to be zoomed in so big on the screen you guys won't be able to see but 2 or 3 words. Let's go and look at those graphs again. Do you guys want to talk about Stony Brook first, or do you want to talk about Millbrook first? Stony Brook. All right, so I'm looking at this. What do you think? I'm looking at this. It goes up, it comes down. We've got this weird little bump here, but I think it looks pretty balanced. That was weird little blip right here. But I would say that this one, for the most part, looks symmetric. It doesn't look skewed because my big bump is right here, and I've got tails off on either end. And I wouldn't say that this tail is like drug out way past where the big bump of data is. Yes, sir.
Okay, so to count it as symmetric, if there's like something in the middle and there's like stuff on the side, even if the stuff on the sides aren't like the exact same height, that's still counted as symmetric.
Again, we're going for like, give me the basic shape, like approximately here. So what I'm looking for is, does it look more like this? More like this, or more like this? Like, where's my big bump of data at? And again, we're just talking about like, it looks roughly like this, it looks approximately like this. I would say that Stony Brook has more of a symmetric shape to it than, say, Millbrook does. When I look at Millbrook, here's my bump. Most of my data ends right here, and then we've got those 2 off by themselves. So I think Millbrook looks more skewed to me when I'm looking at where's most of this data. I'm usually not looking for like this one weird outlier or even 2 weird outliers there. Yes?
So on the test, when you're writing your answer, so like say for Stony Brook, somebody felt like it has a right skew, would that be counted as incorrect even if they like you saw the right way?
No. No. What I would really want to see, if you're describing this as a right skew, I'd really like to see you draw over the top of it like this. And that's kind of where you're getting it from. Because then I can see, like, if you draw it like this, I see the big bump right here. And if it's drawn like that, it does kind of look like there's more of a tail off to the right. So I would take right skewed, or I would take approximately symmetric. Looks either one. Which one do you guys want to go with for our purposes here? Symmetric sounds good. Distribution of nitrate concentrations for Stony Brook. Is approximately symmetric, or again, you could say approximately, or is, skewed to the right. Oh my goodness, come on. Approximately symmetric.
Can we abbreviate like that on the test?
APPROX, I would say that's enough. Statisticians do abbreviate a lot. I would say as long as it's a fairly standard abbreviation that nobody's going to have to guess at what word you're meaning, you'd be probably pretty safe. I'm not going to take off any points for abbreviating the word approximately. I know y'all are going to be flying through this test and getting to the writing part, and you're looking at how can I get the most words down to explain this as quickly as you can. So, all right, approximately symmetric, whereas there's some comparative language, or while. How did we describe the other one? What do you think? It looks like it has more of a left skew. Whereas Millbrook is skewed left. If you look at my answer key, I've got things worded a little bit different. When I looked at this before, I was like, oh, I think Stony Brook has a right skew and Millbrook looks kind of approximately symmetric. I'm looking for like, what's your analysis? Can you back it up with some stuff? Like if you've got some drawings over the top of it, just be able to back it up. If I can see where you got it from and I was like, yeah, well, that does kind of have that shape, we're good. We're good. All right. So we've got our shape. Do you guys want to talk about, like, what do you want to talk about next? We need to talk about outliers, center, and spread still, and it doesn't matter the order that we do it in. Outliers. Let's go back and look at the graph. Stony Brook. Potential outliers? Not really. Millbrook. Yes. Looks like there's possibly 2 high outliers at about 18 and at about 20. Nitrates. Results. Oh, there we go. They're using milligrams per liter. So now I've got some units here that I can put on there. So I would say Stony Brook has no outliers. But Millbrook has 2 potential outliers. Why am I saying potential instead of saying they're definitely outliers? I didn't calculate it. If you want to calculate it, you can. On A, you calculated it? I mean, I'm not looking at A right now. I'm just looking at part C here. Determine if they're outliers? Sorry, I'm looking just at this part right now. Are either one of these outliers? 20 is an outlier. 18 is or is not? It's not. Is it like right on the line? 19.5 when you calculate for those outliers. Look at that. Yeah. So 18 is not an outlier, but 20 is. So with that information, Stony Brook has, I'm not going to say 2 potential, I'm going to say 1 outlier at 20 milligrams per liter. Will you get out of the way now? No, you're still going to be difficult. Okay. We've talked about shape. We've compared those between the two. We've talked about outliers. We've compared those between the two. Centers. Which centers should I be comparing here? What do you think? I would probably compare the median. We have access to all the information, so if you compared the means, that wouldn't be, like, you're talking about the center there. But because we have the one that has the skew, I would probably compare medians there. So going back up and looking at the mini-tab data, give me some comparative language I could use here. I love it. Sorry, that's probably zoomed in way far. The median for Millbrook, and then I'm going to stick in parentheses right here, which was what, like 8.25 milligrams per liter is greater than Stony Brook's. That was 5 milligrams per liter. And then we need to talk about the spread. pieces of information that we have access to. We have access to all of the possible ways of describing spread. We are given in the mini-tab data up here the standard deviations. So I could compare my standard deviations. We've got Q1 and Q3 here on part B. You're doing box plots, so you have access to be able to calculate the IQR pretty quickly. How do you find IQR again? Q3 minus Q1. So we're looking at the edges of the box, big one minus the small one. We can also calculate the range. How do you calculate range? Maximum minus minimum. So just looking at that right there, I could talk about range too. Usually we want to talk about either standard deviation or IQR. Range is sometimes all we have information about, and so we'll talk about the range then. It's not wrong to talk about the range. If you could grab that, that'd be great. Since we compared medians, I would probably compare IQRs when I'm talking about variability. If we had compared means, then I would probably compare standard deviations. That'd be what I would lean towards. So let's go find the IQR for Stony Brook and Millbrook. So IQR for Stony Brook, that one is 4, 7.5 minus 3.5. IQR for Millbrook would be what? 6. 10.5 minus 4.5. Yes?
So do you use the outliers in the shape when you're talking about it or no?
You can fit that, like, there's nothing saying that you have to have one sentence for each of these pieces. You just have to hit all those points. So if you wanted to talk about the outliers when you're talking about the shape, you can absolutely do that. If you took it all the way over there, yeah, you could, like if I saw on yours and you're like, well, there's this and then this is trailing out, so my big bump is here and I've got tails on both sides, I would accept it's approximately symmetric. Again, I want to see what you're seeing as you're describing that situation, as you're describing that distribution to me. If it's really, really obvious, then I would expect like one of the three and that only that one. But it would have to be a really obvious one. Yes? Yes. All right, so which data would be described since we used, oh my goodness, that's zoomed in way far. We already used greater than. Are you guys okay if we go with like a less than or smaller than? All right, so which one has less variability? Which one had the IQR of 4? Stony Brook. Okay, so
variability has to do with IQR.
yes, variability is either IQR or standard deviation or range. We're talking about how spread out it is.
So the less the IQR is, the variability.
Yes, the smaller the IQR, the smaller the variability. Same thing with standard deviation. The smaller the standard deviation, the smaller the variability. Same thing with range if that's all we have to compare. So Stony Brook has less variability. I feel like I'm writing like a 3-year-old on the board. Stony Brook has less variability. IQR 4 milligrams per liter than Millbrook.
And that's it. That's all we have to write for the.
Yep.
For the
6 milligrams per liter. Yeah, it's really just compare contrast. It's like a compare contrast paragraph, and I'm telling you exactly what 4 things I want you to compare and contrast. Yeah. Definitely want to get that comparative language in there. I've hit context up in that first sentence, the distribution of nitrate concentrations, and also anywhere I stuck in that milligrams per liter, I'm getting that context in there. So as long as you're using units and you start off by saying, what are we even looking at? When we're talking about SOX, it's always the distribution of whatever, whatever. All right, number 13. The 5-number summary for scores on a math exam is 11, 35, 61, 70, 79. Hold up, back up. What are those 5 numbers? When they say the 5-number summary and then they just spit out these 5 numbers at me, what are they telling me? Yep, I have minimum, Q1, median, Q3, and maximum. And it's in the same order when they talk about the English exam. It's always minimum first, then Q1, median, Q3, maximum. So basically with what they just told me, without the picture, they just told me what the box plot looks like. And I could kind of sketch it out if I wanted to. Are there any outliers on the English exam? What do we use for outliers? IQR, what about the IQR? Got to do something special to it. 1.5 IQR rule. Oops, 1.5 times the IQR rule. Which numbers do I want to subtract to find the IQR for English? Close. You're off by 1. Q1 and Q3. 51 and 79, yes. Because we do Q1 minus Q3 for the IQ. Sorry, Q3 minus Q1, my bad. Thank you. Q3 minus Q1 for the IQR. If you subtract it the other way, you're going to get the same number, just a negative. Just IQR is not negative. When I'm talking about how wide the box is, it's not a negative. So if you screw it up and do it backwards, but you report the IQR as a positive value, we're good. All right, so 79 minus 52. What is 79 minus 52? 27. So here's my IQR. And so if I do 1.5 times 27, you said 40.5? All right, 40.5. So I'm going to check for low outliers first. Since I don't have all the raw data, the only outlier that I could potentially identify would be that minimum. Because I have that data point, I have the maximum data point, I know that came from the raw data. I don't know any of the other pieces of raw data. So low outliers. What do I do with that 40.5? Try to figure out low outliers. Subtract it from 52. So 52 minus 40.5, which would be, what, 11.5? What was the minimum there? 35. No low outliers. Oh my goodness, my handwriting is so bad. And then checking for high outliers. How does the process change when I'm talking about high outliers? You add it to what? Q3, so 79 plus 40.5. So what, 119.5? Is that right when I add those? Please help me, I'm doing this without a calculator. Okay. What was the maximum? 91. Do we have any high outliers? No. The maximum is not above that. The minimum is not below the other one. No high outliers. So the overall answer to this would be what? No. Any outliers? Nope. Part B. Uh-huh. I will tell you that they are absolute sticklers on the AP exam. If they ask you a question that has a yes/no answer to it, they want to see a yes or a no there. So yeah, I would absolutely put, like, if this was part of a question on the AP exam, I would actually answer that as a full sentence. I would still show all my work to support my answer, but then I would say, no, there are no outliers, period. That's what I would put. But yeah, I absolutely did see people get dinged if they did all the work and they had the work that was showing that there were no outliers, but then they didn't actually say that. They got like a 3 out of 4 on that question. On the math exam, so we're talking approximately here, about how many had scores between 35 and 61. So here's my math. Here's 35. Here's 61. Which pieces are we comparing? Q1 and the median. So I just want to revisit what we had talked about with box plots. Median takes all of my data and cuts it in half. What does Q1 do? Cuts that half, cuts the smaller half in half. If I cut something in half, I have what percentage of it? 50%. If I take 50% and I cut it in half again, I have 25%. So about 25%. Mark the following statements as true, false, or cannot be determined, and we'll use a C for that. So we got 5 of these. I don't know why that one is up there. Whatever. Probably so I could fit it all on one page, honestly. The mean test score for English is about 70. What do you guys think? Cannot determine. I would go with cannot determine here. What'd you say? Oh, sorry, I thought you said false. I would also accept false on this one. So I would accept C or F. C, because with the information given, do we have the mean? I don't know what the mean is. Cannot determine what the mean is. I don't have the raw data, so I can't add it all and divide. I could go with a false on this one also, because look at the distance between the minimum and the median. How far apart? 35. Is this 35? Is it less or greater? Less. So the median is closer to my maximum. So I know that most of, like, I have a big bump of data, like over here in these high scores. It's going to be like there's less variability there. I'm going to see it all scrunched together. Half of my data in a histogram, that's where the bars would go really high, but it would be really narrow because they're all packed into that space. And then this half of the data is trailing off from 70 down to 35. So I would see more of a tail. That 50% is stretched out over more. If you have a tail that stretches off to the left, stretches into the smaller numbers, how will that compare? Like, how will the mean and the median compare to each other? Mean is always going to be the middle, right? What would happen to the average if I have a tail off to the smaller numbers? Think about your test grades. If you got a bunch of high test grades and then you score a 0, what happens to your average, your grade? It goes down. When you have a tail off to the low numbers, off to the left, thank you, Brandon. Tail off to the low numbers, or you have an outlier on the low side, it's going to pull the average down, but it's not really going to move the middle very much because you cross off and get to the middle. That's not going to be as affected. So you could also say that we know this is false because the mean would be pulled down by that really low English score. About 50% of the English scores are between 52 and 70. Would that be half of the English scores? No. That would be a false. About 25% of the English scores are bigger than the lowest math score. Lucy, you're saying no. I agree with you. I think that's another false one. What percent of the English scores are above the lowest math score? 100% of them. All of them. There wasn't a single English score that was below an 11 or even at an 11. The minimum here is like 75% of that. It's like they're lower by 25% there. One of the math scores was 48. They're just telling me that. That's not the true false part. If that score is removed, the median, the middle, is still 61. Cannot determine. Don't know. I have no idea how many pieces of data they had. For all I know, they had a whole bunch of them that were 61. And as they cross off and get to the middle, if I take one away, it's still falling in 61. Maybe it's not. Maybe it was right on the line there, and removing that one piece would bump it. And then the last one over here. For math, the mean is lower than the median. That one is true. How do we know? Half of my data for math is in between what two scores? Here's my median. Where's my maximum? 79. From 61 to 79, half of the students scored between a 61 and a 79. The other half of the students, how spread out was that? Much more spread out, somewhere between a 61 and an 11. That's a spread of 50 points, right? 61 to 79 is only a spread of 18 points. So going from the middle down to the bottom, it's much more spread out. That means I have a tail in that direction. So it's going to pull the mean down. Whichever direction the tail goes, that's the way the mean goes. You guys, maybe I'm going to date myself with this one because memes like come and go super fast. Have you guys seen the distracted girlfriend meme? Or sorry, distracted boyfriend meme? He's walking down the street holding hands and he's like checking out the other girl. So I saw one that they had made for stats. The girlfriend is the median. He is the mean. And the girl that he's looking at is the outliers or the tail. He's moving in the direction of the tail. So whatever way the tail goes, that's the way your mean is going to go. It's going to get pulled in that direction. Does that make sense? If it's a right skew, mean's going to go up because that's where the bigger numbers are. If it's symmetric, the mean and median will be about the same. It's going to be close enough that like, it's close enough to the same number. It might not be exactly the same because the mean might be like 31.889 and the median is 31 or 32 or 31.5. Yes, the mean is going to go in the direction of the skew, but I want to know what's typical. And so if I've got this pull in one direction, that's not going to tell me what's typical or what's expected. What else did you guys want to talk about? We have about 9 minutes left. That's 1 or 2 problems, depending. Yes? For number 4, how do we know that the median stays the same? A sample of 99 distances has a mean of 24 feet and a median of 24.5 feet. Unfortunately, it has just been discovered that the maximum value in the distribution, which was erroneously recorded as 40, actually had a value of 50. All right, I'm going to do some mock raw data here so that we can kind of see what happens. So we've got median is 24. Let's pretend we have a 21 and a 10. We've got a 35, and originally this is recorded as 40, right? So here's my middle. If I take this away, but I replace it with a 50, did the middle move? When I cross out to go to the middle, because I'm replacing that maximum. Let's back up here. If I took this one out, but I added one over here, would that change where my median is? So as long as I'm staying on the same side of the median and I'm doing any like remove and replace, but I'm only on the bigger side of the median, or I'm only on the smaller side of the median, it's not going to move where the middle is, because I'm still crossing out the same number of pieces to get to that middle. What would happen to the standard deviation? Thoughts? How far away is 40 from 24? 16, right? 16 away from 24 to 40. How far away is 50 from 24? That one's 26. So if I'm talking about the average distance away from the middle, what just happened to my average distance? It got bigger because I added something that was farther away. If they had said, this is actually 37, that's going to be closer to my middle, so that would make my standard deviation smaller. Standard deviation would get bigger. What would happen to the IQR? Stays the same. Standard deviation and mean are going to change when my values change, because those are averages. I'm adding things up and dividing. Standard deviation, I'm still adding up and dividing, but now I'm like subtracting, squaring, adding, dividing, square rooting, but I'm still adding and dividing. I'm still talking about an average here. The IQR, we cross off to get to the center, right? Well, if this is my median, Q3 is going to be in between these two, right? Q1 is going to be in between these two. Remember, we got 99 pieces of data. If I take one out and replace it with another and I cross out to get to the center, I'm not moving that at all, because I just took out the top piece and put a different number in its spot, but it's still just the first one I'll cross out. So IQR stays the same. All right, what else? Got 6 minutes left. Yes. 15B. Calculate the conditional distributions. That's part A. Discuss the relationship between age group and amount of violence watched in 2 or 3 sentences. Be sure to discuss if there is an association between age group, and violence watched. Okay, so you kind of have to do part A in order to be able to answer part B. So I'm going to answer part A real quick. So as I look at my age groups, what are my age groups? 16 to 34, 35 to 54, 55 and over, so 55 plus. So there's my age groups. 16 to 34, low and high right here. So low, that would be 8 over 26, and high would be 18 over 26. And then I need to calculate those percentages, because I don't want to compare the fractions, I want to compare the percentages. So I've got like, this is like 30.8%. And then we've got like 69.2%. 35 to 54. My low, I'm looking at 12 out of 27. And for the high, I'd have 15 out of 27. So this looks much more, almost like a 50-50 split. I've got 44.4% here. And I've got 55.8% 7.6% here. And then 55 and over. Low, 21 out of 28. That's 75%. And high, we had 7 out of 28, which is 25%. Something I want to point out, since we only have two categories on this variable, high and low, if I calculate this one, I wouldn't have to do the fraction to get this percentage. What could I do to get that percentage without setting that up? Subtract it from 100. Since there's only two categories to pick from, if I know that one, I automatically know that one because it has to add up to 100%. All right, so there's my percentages. So just looking at this right here, which age group watches more violence? 16 to 34 definitely watches more high violence, right? Which one watches the least amount of violence? 55 and plus. Is there a relationship? If I know what age group somebody falls into, could I make a better prediction about whether they watch high or low violence? Yes, so I would say there's definitely an association here, because if I know somebody is in that 55 plus category, I'm like, I'm going to hedge my bets that you're probably in the low violence category. I might not be right, but I'm going to make a better, more accurate guess by knowing which age group they fall into. Very quickly, before the bell rings, I do want to show you guys where the answer key for this is.